This I think they have done in lower sec. So then there is this three states of matter where you have to do they talk about solid, liquid, and gases, and then their properties. So the properties like this in this table. So do you know what these are, or should I explain it? Should I
Explain.
explain? So okay, let's not talk about the kinetic model theory first, of matter first. So what in primary school science or in secondary sec 1 sec 2 science, they will have this three states of matter. So three states of matter, then which is solid, liquid, gas, which is here, you know, it's labeled down here, solid, liquid, gases. These three things. So okay, so what happened is they tell you that solids probably look like this, then the shape is always fixed. That means if I have a cube, it will always look like a cube. It will not change into something else unless I take a knife or I take a pair of scissors or I take something to reshape it. If not, the shape is always the same. So that's why you have this thing called shape is the shape of the solid is fixed. So then the volume, say this is 500 ml. So the volume is 500 ml. So that means if I were to take put this under a tap, then I run water through it. So I pour water inside. So the volume of water that will fit into this cube will be 500 ml. Not a drop more, not a drop less. It is always 500 at maximum capacity. So the volume doesn't change. So when volume doesn't change, that means the volume is fixed. So that's why you have this. Okay. Then the solids being incompressible is like this. Okay. So I have to, okay. What happened is like this. This one was like this just now as, okay, let's say 500 cm cube here. Incompressible for solid means I take this, I put the force. I exert force in whichever direction. The shape remains the same and the shape does the block does not decrease in size, doesn't become smaller. Therefore, it is not compressible.
Yeah.
So that's that first three ticks down there. Then density is 1 mass per unit volume, or in diagrams, if we want to talk about density, I would draw something to it to show an example. Let's say okay, two shapes, two substances here. Okay, so density is mass per unit volume. That means it's the amount of substance packed in a fixed area of volume. So if you have, so that means, right, this one, in this drawing, that means it's high amount of substance packed in a fixed area, per fixed area. Then this is the low amount of substance in a fixed area. Okay, so that means, right, if the density, if there is high amount of substance in a fixed area or volume, that means this is high density. This is low density. So in that case, in the case of solids, right, they are considered high density. That means that there are no empty spaces inside the solid. Everything is packed together. So that explains high density. But density will be better explained with the kinetic model of matter later. So this is solids. 1, 2, 3, 4, 4 points. Do I need to further elaborate on anything down there? Do I make more sense right now to you? Can I? Can I'll go to the next 4 points in liquids. You see liquids as in just now the water flowing out from the tap. Okay, pardon me, drawing horrible. So water from the tap. Okay, so if I pour the water into a square box or square container, the water will take the shape of the container, right? If I put it into another one, the container, the cross section is round, circular. So then the water will take the shape of the circular container, right? If I have another one, which is like that, the container, so the water will come in and also take the shape, the shape of this container. Am I right to say so? Say correct, huh? So the liquid takes the shape of the container. So if that happens, we can say that it has no fixed shape. So again goes just now that that example of a square container, round container. So I got the tap and then I measured 500 cm cube of water I poured inside here. Then I take this container filled with 500 cm cube of water or 500 ml of water. I take it and then I pour it over here to a round container. Then if I pour out again and measure with a measuring cylinder of the water inside here, assuming that no water spills, I will get 500 cm cube of water in the round container. So which means, right, the volume before and the volume after doesn't change. So volume is fixed. Then the compressible and incompressible. We can, let's say, whether it's compressible or incompressible, that means the phenomenon is observed when I have, let's say, a syringe. then a syringe with a plunger. Seen this before, right? Have you seen this kind of object before?
Okay.
Yeah. So I fill it up with water. Then I put my finger here. Okay, sorry, pardon me, bad drawing. Then I apply a force here. What will you observe? Will the plunger go in if I apply a force down there? But by right it shouldn't. So the plunger will not move towards the left. So that means, right, it indicates that the volume does not change when you force it to change. So therefore, that means it's not compressible or incompressible. Okay. Density will be explained using particulate model of matter. So I will explain later. Then for gases, gases is relatively easy. Gases behave uh, like liquids. So you can, let's say I have balloons. Then we have this kind of weird shaped balloons. And what kind of shape? What other shape I have? Then sometimes they have those aeroplane balloons, etc., etc. So you pump. So to fill up balloons, you pump in air. So in whichever shape the balloon is, the air will just take the shape of the balloon, thus giving you balloons of all different shapes and size and variety. So that one will tell you that the shape is not fixed. Okay. So then the part about the volume of gases is not fixed and being compressible, this too is one explanation. So we will get rid of one balloon here. So then I would use my hand and then try to squeeze the balloon. Then we will find that the balloon becomes smaller, a little smaller, before it bursts. So that means, right, the volume isn't fixed because you can, by compression, cause the volume to become smaller. So being able to, that means not fixed. So being able to compress means that the gas is compressible. Then if I have a small container, I pump air, a small container, the small container like this. Okay, then after that I have a bigger container, then I transfer this over. This air will then fill up the bigger container, which will tell you that it occupies the volume of the container. So you have a big container, small container, the same amount of air will just readjust because it's compressible. Then low density is explained later. Okay. Can this table okay?
Yeah.
Okay. So I'm going to erase everything. Okay, back to the top part. This part where you talk about your definition. This section. So you have this thing called kinetic model of matter. What it says is that all metals are made up of tiny atoms, tiny molecules or particles. So they say like this, anything is made up of round things like atoms and molecules. So these molecules, atoms, and particles, any substance. So these molecules, or what, they are always moving in continuous random motion. This is what they say. Say any substance, in the molecules, the particles, or the atoms inside will be moving in continuous random motion. But the thing is, right, the how they move is dependent on whether they are solid, whether they are liquid, or whether they are gases. So then you have to learn individually the characteristics of the three states. So when they ask for the definition of kinetic model of matter, right, you will give them this definition word for word, line by line. Then you are totally fine. Say, please state what is kinetic model of matter. You just give this answer. Something like that. So as I said, the kinetic model of matter will be used to explain the physical properties, these things here. You explain this later. So they will help you to explain why liquids has fixed volume, non-fixed shape, and etc. Okay. So because the atoms can gain energy or lose energy, they can move either fast or slow. So there comes this part about effect of temperature on molecular motion. So molecules will have different speeds due to different Ke. That one I'll explain later. But for now, you must know the temperature is inversely proportional to Ke of atoms, which means in easier terms, it means high temperature particle K increase Ke, particles move faster. So low temperature, the Ke will be reduced, then particles move slowly. Okay, that is for this page. Okay. Okay. Can? Okay. So you have, this is the particulate model of matter. They examine it in terms of solid, liquid, and gases. So if you were to if you were to take a microscope. Then you get a big flask and you get some solid. Even you probably not the normal microscope, you may need a transmission electron microscope. If you are interested, you can go and find out. You are likely required to have a transmission electron microscope. Then you take a solid and you zoom in, and you will see that the particles inside a solid are arranged similar to this. So similar to this, but not exactly like this. So same goes for liquid and gases. If you were to take a very high powered microscope and look at them, you will get something similar. The image will look something similar to the diagrams you have here. The only difference is this is simplified, and they simplified the diagram so that they look very palatable to you. So in solids, they will say that, or rather it's an observation, they find that the particles, the atoms are packed very, very close to, like close, and they are in regular arrangement. That's why they say they are closely packed and in a regular pattern, with hardly any, with little amount of space in between. So then remember, just now I talked about density. High density means it's everything packed very, very close together. A lot of substance in a fixed volume. A lot of particles in a fixed volume. So just now I said a lot of particles in a fixed volume is equivalent to high density. So with that logic, you look at your solid down here and the arrangement of the solid, you will see that the solids are arranged very, very close together, and they say very little space in between. So you pack a lot of them in one fixed area. So because of that, then it has high density, as we assume. Okay. Okay. They are closely packed with in a regular pattern. So this is classified under arrangement. Okay. Then if you were to examine their movement, you will find that all these atoms in a solid, or particles or molecules in a solid, while they are even in their own fixed position, they will kind of move. Because kinetic particle theory says that the atoms or particles are always in continuous random motion. And solid particles are in continuous random motion in their very own way. They just sit down there and vibrate at their fixed position. So they vibrate. So they constantly bobbing up and down. So this is what they mean here. They vibrate about fixed position. Then why they are in fixed position is because they have this thing called intermolecular bonds in between. You could assume it's covalent bonds. You can assume it's electrostatic forces of attraction from your chemistry. But in physics, we don't talk about bonding. So as in, we don't talk about covalent bonds and ionic bonds. So it is, the blanket term is used called strong intermolecular bonds. So there is like some attractive force in between the atoms in physics. We assume like that. You see, there are some bonds in between. So these bonds are intermolecular bonds. And in solids, they are strong. So because they are strong, it will, the atoms will not move away from each other, so they'll stay in their fixed position. So because you have, they're not moving, as in they're not moving away from their position, so they will have fixed volume and they will have fixed shape. Question, please. Now liquids. In the flask containing liquids, the particles are probably still close to each other with some space in between. You will see that they float, they are arranged in clusters, and they are still kind of or very close. They are slightly further apart if you compare to solids. You look at the pictures, you'll see that the molecules are slightly further apart. The space in between the molecules are still very, very small. So they are still considered as closely packed. Then they are allowed to move, they are in not, okay, they are not in a regular pattern anymore. So because there are still a lot of particles in between, molecules in between, in that fixed volume, and the spacing in between the atoms and molecules are very small, they're still closely packed. So therefore, as what we said earlier about density, they will have relatively high density. Not the density is not as high as in solids, but they are still considered as having high density. Not as high as solids. Okay. Then different thing is, okay, so 1 second ago the arrangement of liquid molecules may be like this. Then after that, the next moment they can shift. So all these atoms or molecules, they can move. So they randomly move past each other, and then the next moment it can look like this. So therefore they say that the particles are free to move randomly past one another within a liquid. Then they still have, there are still forces in between, like my green dotty lines that I draw, they still have intermolecular bonds in between. But these bonds are weaker than those in solid state. Then because they are very close together, they will have fixed volume, but their movement, the ability to move for the atoms, right? The atoms' ability to move will will cause them to take the shape of any container that they are in. Okay. Then the last part is gases. So gases, gases. In gases, now they are the particles are very very far away from each other. So because they are very very far away from each other, there is a lot of space in between. So remember just now when I say density, low density means very little particles inside the fixed volume. So low amount, there's little amount of substance. In a fixed volume. So which is exactly the same as the how the particles are arranged in a gas. So there are very little particles, not many of them in a fixed volume. So because of that, right, they have low density. And this bunch, these particles, they are moving everywhere randomly. You can move anywhere. They vibrate and then they move in all sorts of directions. So we say that it is in random continuous motion. So at high speeds, so they move very fast. So this one, the liquid will be medium speed, low speed. Then remember the forces in between, the attractive forces. Attractive forces are hardly there. So that's why you have these here. Then they can move anywhere to fill up any space. How to fill up any space is like this. Let's say now I have a smaller container. So you see the container is significantly smaller. So I have 1, 2, 3, 4, 5. So what happened is now they will go to the smaller container and then they'll just take the shape and take the volume of the new container. And then they continue move at their own random motion. So therefore, because of this, right, you can say that they occupy whatever space they have, whatever volume they have. So this results in them having no fixed volume and then no fixed shape, and then they are highly compressible because they just reduce the spacing between the atoms so that they can fit in a new container. So if you have a bigger container, a ginormous container, so what happens is the 5 will just take the volume of the space of the 5. Now the big volume down there, the 5 atoms will just take it and move in, and they redistribute in their space. Okay. Okay. Can I'll give you 1 minute again. You digest and then you ask me any questions or you make me explain whatever again if you require.